Hello, everyone. It's 1 p.m. Eastern, and that means it's time to begin our 68th CoCoRaHS Weather Talk webinar. A very warm welcome to those of you joining us today. I'm your host, meteorologist Henry Regis. Running the technical side of our program is our very own Noah Newman. We're coming to you live from the Colorado Climate Center here at Colorado State University in sunny Fort Collins, Colorado. For those of you who are unable to join us for our live broadcast, we are recording today's talk, and it will be available later this week on our website. All of our Weather Talk webinars are sponsored by generous gifts from donors just like you. Well, today's webinar is on hunting hurricanes, and we have a real treat for you. We're privileged to have with us Warren Madden. Warren is a native of Braintree, Massachusetts, just south of Boston. He holds degrees from MIT, Penn State, and Wright State University. You may recognize him from the Weather Channel, where he spent 10 years as an on-air meteorologist. During his years in television, Warren remained in the U.S. Air Force Reserve, and in 1998 joined the hurricane hunters of the 53rd Weather Reconnaissance Squadron. He served as an aerial reconnaissance weather officer until his retirement as a lieutenant colonel in 2012. He flew over 1,000 hours, including missions into Hurricanes Rita, Ivan, Wilma, Floyd, and Typhoon Maggie. Currently, Warren leads the Air Force's Chief Aerial Reconnaissance Coordination All Hurricanes Unit at NOAA's National Hurricane Center in Miami, Florida. Warren, it's great to have you with us today. Let's give him a warm welcome. And, I usually start off with this very question for all of our guests. How did you become interested in weather?
Well, good afternoon or good morning, or depending upon where you're located, it might even be good evening. Yeah, it was an interesting story getting me interested in the weather. I was actually growing up in Boston, just a little small town to the south of Boston at the time. And I learned to read at a reasonably early age. And one of the things that I liked to look at every day was the newspaper, because it was something good to read every day that was new. And sure, I started off looking at just the comics, but gradually I would start looking at other things. And of course, the front page was one thing. And one day on the front page, I was probably about 6 years old, there was a story about a big tornado in Texas. On the front page, there was this picture of a house. Well, it was what was left of a house after the tornado got through with it. It was just a shell, really, some walls, a bit of roof here and there. And I was just floored looking at that saying, wow, the wind can do that? And the next thing you know, I was headed straight to the library, and I was checking out every book I could find on tornadoes and the weather. And that really started a love of the weather that has lasted me now for, over half a century. Yeah, I'm getting old. But yeah, I've been very fortunate to be able to, from those early days of watching the clouds and learning the cloud names all the way to flying through hurricanes, I've been able to take my passion for the weather and turn it into a lifetime of a career and experiences. So very pleased to bring you some of those experiences here today with my talk on hunting hurricanes, heading straight into the eye of the storm. As Henry mentioned, my name's Warren Madden. I'm a retired lieutenant colonel in the Air Force, and I used to fly into hurricanes. So let's start off with a little bit of a quick virtual survey. And so,
hey, Warren, I'm going to interrupt you real quick. If I could just get your volume up just a little bit more.
Okay, how's that? Is that any better?
Oh, there we go. Very good. Okay.
All right, I guess my microphone drifted away a little bit. Okay, so now we'll pick it up again. Okay, so our first off survey. Have you ever, and first question is, have you ever traveled on an airplane? Now, of course, I've got full screen here, so I can't see all of the hands going up, but I'm imagining a fair amount of you have raised your hands. Now, how about the second question? How many of you have gone through a car wash? Again, I expect many of you are virtually raising your hands here. And then the third question, how many of you have taken a ride on a roller coaster? Yeah, I used to live in Ohio, so I got to ride on some big ones, especially down around Kings Island. Never made it up to Cedar Point, though, but those are some big roller coasters. But now here's the payoff question. How many of you have done all three at the same time? And I imagine there's a lot of hands going down. And usually when I give this talk in person, when the people come to do tours at the Hurricane Center, especially if I have kids coming in from school, especially the younger kids, one or two of them will try to sneak their hands up. And I'm like, really? Really? And then they have to kind of pull it down. Well, I honestly can say that I have, because that's kind of like what flying through a hurricane is. Being on an airplane, in a car wash, on a roller coaster. So I was trained in the military how to give briefings. So we were always taught to tell them what you're going to tell them about it, and then tell them what you told them. So here, I'm telling you what I'm going to tell you. I'm going to tell you about how it all started. We'll look at the aircraft through the years. What aircraft we've used to fly through these storms. Then we'll focus in on the squadrons as they exist today. Talk a bit more about the mission and how we conduct it. And any good talk, when you talk to a pilot or an aviator, there's got to be some there I was moments talking about my experiences flying through storms. And then we'll wrap it up with some final thoughts before we turn it over to your questions.
Warren?
So let's, yes.
Oh, sorry, this is Noah. Just a quick technical issue here. If you could just possibly slow down just a tad, I think your microphone is tapping in and out just because of how fast the words are coming out, possibly.
You're asking me to slow down. That's a tough sell. All right, well, I'll try to be a bit more, shall we say, broad here. Okay, all right, so let's talk about how it all started. How did we get into the business of flying into hurricanes? Well, we'll cue that. If you ever watch TV shows, you hear that harp music as they dissolve back to years previously. So imagine that harp music. That's a good idea. I've got to find that to add that into this this video at some point. So it all started on a bet. Bet you can't fly into that hurricane. We're back in World War II, July 27th, 1943. That was the day. Try to do my best Walter Cronkite impersonation here. So there was a hurricane that was off the coast of Galveston, Texas, and it was heading in to make landfall. Now, of course, this being World War II, there were a lot of military facilities in Texas, a lot of training going on. And one of those facilities was in Bryan, Texas, inland from Houston a bit, not too far from where Texas A&M University is now. And there was an Army Air Corps instrument training school. The Army Air Corps, of course, was the precursor to the Air Force, which wasn't formed until 1947. And on this base, they taught pilots how to fly without being able to see the ground, to fly in clouds with just using their instruments. And not only were there American pilots training there, but there were also British pilots training there. And the discussion on this morning, July 27th, was whether or not they would have to evacuate the aircraft with this hurricane coming in with high winds. Well, the British pilots, well, they thought, gee, wow, you know, we fly in winds like this up in the North Sea and stuff a lot. Your planes must not be all that great. Well, the commander of the school, Colonel Joe Duckworth, got word of this, and he was, shall we say, not pleased. He thought he had a fine aircraft in the AT-6 Texan trainer that they flew at the school. And he did not like that the British were, in effect, dissing the aircraft that they were using. So he decided that the best way to prove that his aircraft was a sturdy and reliable aircraft was to fly it into that hurricane. And he bet the British that he couldn't do that safely. Now, I suspect that the bet involved around drinks at the officers' club afterwards, but we don't know that for sure, but I wouldn't be surprised at all. So the bet was made, and Colonel Duckworth went to his navigator, Second Lieutenant Ralph O'Hare, and said, we're going to fly into that hurricane. So they hopped into the plane, fired up the engine, went out, tooled around in the hurricane for a while, came back and landed, and yay, they win the bet, end of story. Ah, but wait, it is not the end of the story, because Colonel Duckworth went out there and said, this is actually kind of interesting. I know somebody who I think would get a lot out of this. So he went to the base meteorologist, First Lieutenant William Jones Burdick, and said, Lieutenant, I think you need to come out into this hurricane with me. There's some valuable weather information to be gained. And so Burdick agreed. And so he hopped in the back seat, and Colonel Duckworth went out and took him into the hurricane for the second intentional penetration of a hurricane. So the first intentional flight into a hurricane was done to win a bet. But the second intentional penetration was done because the base meteorologist thought it'd be a cool thing to do. So who was crazier? There's the question. Well, we've continued that craziness, as some may term it, for getting now close to 80 years. And we've flown a variety of aircraft into storms with all the same mission to find out what's going on inside those storms, how strong they are, and where they are going. So in the early years, One of the planes they flew was the B-25 Mitchell bomber, twin-engine bomber. If you've ever, some of our older viewers might recall, if they've ever watched the movie Catch-22, that was the type of aircraft that they were flying out of bases in Africa. In this case, some of the first flights of the B-25 were into a great hurricane that was off the East Coast in 1944. And they're credited with saving a fair amount of lives by providing better information than was previously available by just ships being out there. Later on, they went to a more long-range bomber. This is the B-50, the WB-50, which is basically an upgraded version of the B-29 bomber that flew many missions against Japan in the late part of World War II. This is retrofitted for the weather reconnaissance mission, a much longer range and fairly good for flying typhoons out in the Pacific, where the storms may be far away from the few island bases where these were based out of. And then as time moved on, the Navy also got into the mission. Now, of course, the Navy is intensely interested in what's going on with typhoons. The historians among us might recall Admiral Halsey's encounters with a couple of typhoons late in World War II that unfortunately caused the loss of many men and at least 3 destroyers who went down in the typhoon of 1944. When the Navy started flying them, a couple of planes that they used were the C-121 Constellation, or as affectionately known, the Connie, a very distinctive triple tail. That was flown into hurricanes. And also a patrol plane, the Navy P-2 Neptune, was flown into the storms also. And after a while, the Navy decided to get out of the mission of flying into storms and leave that to the Air Force. And in the early 60s, the Air Force shifted to a new bird, the C-130 Hercules. And this plane has been built now for close to 60 years. Over 60 years it's been built at a single plant in Georgia. And I speak with a bit of experience on this because prior to my job here at the Hurricane Center, I used to work at that plant, helping to build these aircraft. This is an H model aircraft, and I can say, looking at that tail number, yes, indeed, I did fly aboard this aircraft into storms. So that is a little bit of the history of what aircraft we have flown into the storms. And now let's move from the historical perspective to today's aircraft and today's missions. So here we have our 2 squadrons. Our first up squadron is my old squadron, the 53rd Weather Reconnaissance Squadron, and they fly the latest version of the C-130, the C-130J, the WC, W standing for the weather variant. There are many, many variants of the C-130, and it's a very reliable aircraft, very new, has good acceleration, and we took delivery of these in the early 90s, or rather the early 2000s, began flying them operationally in 2005, and we'll be flying them, I suspect, for at least a couple of decades more. Very, very sturdy and reliable aircraft, just the kind you'd want when you're several hundred miles from land in the middle of a hurricane. And then we have the NOAA Hurricane Hunters. They fly 2 different types of aircraft. They have the WP-3D. The P-3 Orion is a naval sub-hunting aircraft. That was its original mission, to hunt Soviet submarines. And NOAA has 2 of these that have been repurposed for weather missions, as again evidenced by the W prefix on the aircraft ID. And then the other type of aircraft that NOAA flies is the Gulfstream 4, a high-altitude jet that is not really designed to fly through the storms, but rather around the storms and ahead of the storms. We'll talk a bit more about the missions coming up later in this webinar. So that's the aircraft that are going out into the storms. Now let's talk a bit more about the organizations that do this. First up, I forgot I had this slide in here. This is a good then and now slide. So in the foreground, you see, guess what? It's an AT-6 Texan. That is the type of aircraft that made the first intentional penetration of a hurricane, courtesy of Colonel Joe Duckworth. And behind we have one of our modern WC-130J aircraft, as you can see. Notice those propellers, how they're kind of scimitar shaped. They're actually composite. They're not made of metal. They're made of carbon fiber. And they are very efficient in pulling through the air. And I tell you, when we get into a hurricane, they get just a ton of rain thrown at them and rain into the engines. It has to be a very sturdy and reliable engine to be able to handle basically having a fire hose pointed to that. All right, so now let's talk about the squadron. First up is my old squadron, the 53rd Weather Reconnaissance Squadron. They're based out of Keesler Air Force Base, Mississippi, and they are part of the United States Air Force Reserve. We have 10 of the WC-130J Hercules, and a total of 20 crews are assigned to the squadron, and it's a split squadron. Half of the squadron are what are called Air Reserve Technicians. They're full-time government employees, and they run the squadron on a day-to-day basis. And then the other half of the squadron are what are known as quote-unquote traditional reservists. I have my webcam on. You'd see me doing the air quotes. And what this means is that, and this is what I was, a traditional reservist. This means that we are bound to go down there at least once a month on a weekend and 2 weeks during, for us, storm season. But as you might imagine, keeping current and keeping proficient at flying into storms takes a bit more effort. So I often put in more time than just the minimum of a weekend a month and 2 weeks a year. So the primary mission of this squadron is tropical weather reconnaissance. And that means going out and finding out where are the storms, where are they going, how strong are they? And so their main mission is going out and acting as the eyes and ears of the Hurricane Center out in the storm. So that is one of our squadrons. Our other squadron are the NOAA Hurricane Hunters. They're the Aircraft Operations Center. And they are based out of Lakeland, Florida. And they are part of the National Oceanic and Atmospheric Administration, NOAA, and they are equipped with 2 of those WP-3Ds I showed you a picture of earlier and 1 Gulfstream 4. Now the crews are all members of the NOAA Corps. Most of you are familiar with the 4 major branches of the U.S. military, the Army, Air Force, Navy, Marines, but then you have several other uniformed corps, such for example the Coast Guard, and another one is the NOAA Corps. So these are commissioned officers who both fly aircraft, and some of them are also going out in the various NOAA ships that are responsible for the oceanic part of the National Oceanic and Atmospheric Administration. So the primary mission of the NOAA Hurricane Hunters is more about science and research into tropical systems. They're going out and they're literally, the aircraft are airborne science labs. They can load different kinds of instruments into them, and they take scientists out to study the storms up close and personal to learn what makes them tick, to better understand them. And that helps improve forecasting techniques. It helps improve computer models. And it also helps us test out new instruments that perhaps will later on be deployed into much wider use. Now, the missions are different, but they are complementary. So, for example, while NOAA is out there doing their science, they're also finding out where the storm is and where it's going and how fast the winds are, and they'll get that information to the forecasters. And then while the Air Force is out there finding the storm, all of the information they collect is available to researchers later on downstream for incorporation into their research. So those are the 2 main flying units, and at this point I'll flip back and mention my own unit, CARCAH. And yeah, it isn't the most wieldy of acronyms, as it were. Chief Aerial Reconnaissance Coordination, all hurricanes. And the key aspect there is the coordination. So we're a 3-person Air Force unit. We're part of the 53rd Weather Reconnaissance Squadron, where it's 3 civilian Air Force employees. So I work for the 53rd Weather Reconnaissance Squadron. We're located right inside the National Hurricane Center so that we can talk directly with the forecasters to find out what their needs are for flights going out there and also getting all the information to them. So we're responsible for coordinating all the flights with NHC. So every morning during hurricane season, myself or one of my other coworkers, we go across the hall and talk to the forecaster on duty and say, what flights do you need? And many days, if things are quiet, hopefully they're quiet, they'll say, you know, we're okay. In which case, we go back and we continue training because as you might imagine, the planes, the crews need a lot of training to be able to do their job safely. But on days when we do need flights, we set those up with both the 53rd and the NOAA squadrons and get those planes out there. And while the planes are out there, all of the data they're collecting flows into our office at the Hurricane Center. We get that data, we perform quality checks on it because of course we want to make sure that it makes sense with the rest of the sensors all around the world and up in space. And then once we're confident that data is good data, we provide it over to the NHC forecasters and it goes out to the rest of the world. All right, so that's what we do in CARCAH. Now, I've been talking a while. Yeah, I'm sure you're saying, okay, I signed up here to come look at hurricanes, and he's just talking about all right, let's take a brief picture interlude here. So this picture I'm showing you right here, this is Hurricane Dorian. And this is a picture of when it was moving slowly, ever so slowly across the Bahamas, and basically acting like a giant, rotary sander on the unfortunate islands of Grand Abaco and Grand Bahama. So this is what it looked like from space, from the GOES-17 satellite, way up 22,000 miles high in space. But for a more personal, up-close picture of it, this is what the inside of that eye looked like from a Hurricane Hunter aircraft. This is called the stadium effect, where imagine you're at the 50-yard line of a big football stadium, and all those stands just towering over you all around, and wherever you look, there's stands rising up. Well, now imagine that those stands are instead the thunderstorms of the eye wall of a hurricane, and that's what we were seeing in the storm like Dorian, where it just you're in the middle of all of this and just looking around and all those thunderstorms, and to get home, you've got to go out through that wall of storms. And oh, by the way, before you get to go home, you're coming back in several more times. I'll talk more about the mission here briefly. All right, and here we are. How about that? We're right into the mission. How's that for a segue? Okay, so it all starts with the plan of the day. Yes, a stentorian voice. This is my product, actually. This comes out from CARCAH, as you can see right up at the top. This is the plan for what we will execute over the next several days. We always plan a day in advance because that takes time for the crews to get ready, prepare the maintenance folks to prepare the aircraft, the crews to get properly rested before they fly out. But we fly these missions, and each of these blocks here documents a mission that an aircraft is going to fly the next day into a storm. So we could have several flights going on. The most complicated pods, we call it a pod, plan of the day, the most complicated ones I've seen have 7 or 8 different flights into 2 or 3 different systems going simultaneously. It can get pretty insane in the aircraft reconnaissance world when all of those aircraft are committed and flying out there and trying to get all that information routed to the right places. So that's how we communicate out to the world what we're going to be flying. But now let's talk about where we fly. So this big kind of reddish oval around here, rounded rectangle, this is our area of responsibility. So we fly all the way from east to the Leeward and Windward Islands out to about 52.5 west. I'll get my mouse going here. Where's my mouse? There's my mouse. So way down here off the northeast coast of South America, we can reach out in here, and we fly all the way west. We're responsible all the way west to the Hawaiian Islands. So the main bases of the aircraft, the 53rd is based here where my mouse is in Keesler Air Force Base, Mississippi. And the NOAA planes are based here in Lakeland in Florida. But we have several operating locations we can move to get to where we need to be to fly the aircraft properly. So one place we can go to is down here into the U.S. Virgin Islands, St. Croix, a forward operating location for the Air Force and sometimes for NOAA. NOAA also will fly out of Barbados. We've got a backup location in Curacao here off the coast of Venezuela in case there's a storm that's affecting the Leeward and Windward Islands, particularly like, for example, Dorian last year did move through the Leeward Islands, and so we had to move the aircraft out of the way so they could continue flying their missions. We also will fly, if there's a hurricane that's going to impact the west coast of Mexico from up around Baja, California, down, whoops, past, let me back up there one. There we go, accidental click. Down past the coast of Acapulco and down here. If there's a hurricane threatening the west coast of Mexico, we'll fly that. Most of the time, we'll fly from Keesler across Mexico to do that, although sometimes we've actually flown from Arizona or Southern California down into this area. And then finally, Hawaii. Many years, we don't go to Hawaii because they don't get affected. But there are some years where they get affected not once, twice, several times. There's 2 types of hurricanes that will usually impact Hawaii. There are those that form here off the west coast of Mexico and then make the long trek westward and impact Hawaii heading from east to west. And then there's ones that will form south of Hawaii and move north. If you remember Hurricane Iniki back in 1992, that was one of the ones that formed in the south of Hawaii and then moved north, and it unfortunately devastated the island of Kauai here at the western end of the chain. So we have a very large area to cover. We'll also cover storms going up the East Coast, like, for example, Hurricane Sandy. When it made landfall here in New Jersey, we were flying that storm right up until the time it made landfall. So we flew out of, for that, we were flying out of Savannah, Georgia here, close to the South Carolina border. So we go to different places to reach where we need to for the actual mission. All right, so let's talk about what's happening inside of the storm. So first up, here's a typical track for the WC-130J. It's basically now for the recon missions, we try to be as consistent as possible because that sort of gives the forecasters less variables to consider. You know, we try to fly the same altitude, usually about 10,000 feet for the stronger storms, and we fly what's called the alpha pattern, which is basically a crisscross, you know, from southeast to north to southeast to northwest or southwest to northeast, and we'll crisscross the storm, usually going through the center 4 times over the course of a mission, gathering data about where the winds are and you know, how strong they are, and then by going through the storm over the period of several times, we'll take these center fixes, which are shown in red, and that will show how the center of the circulation is moving over the course of time. And that helps the forecasters understand the movement of the storm. Typically, the legs that we fly are about 105 nautical miles, or roughly 120 statute miles out from the storm. Now, that's usually gets us well outside the range of the radius of hurricane force winds, but and even tropical storm force winds. But if you'll note here, we were still seeing 55, 60 knots. That's the flag is 50 knots, and of course the you know, then you get up here, well out close to 105. This was Hurricane Ike back in September of 2008, and one of the features of Ike was that it was very, very wide in terms of the strong wind fields. You know, I remember I flew into it, and I was seeing on the northeast corner out here. When I flew it, there were still winds up above 65 knots, so it was still hurricane strength, even over 100 miles out from the hurricane. That was very unusual, and that had some pretty big impacts, and I'll show you a picture of that later so you can understand that better. So that's the kind of flow, that the flight pattern that the WC will fly for these missions. Now let's look at the WP3D, the NOAA Orion. And here you see it's not as clean as you might say. There's a lot more, you know, moving around and everything. And the reason for that, remember, what's the main mission of the NOAA aircraft? It's science. So they have scientists on board conducting experiments, and they may want to focus on a particular area of the storm. They're finding things, and so they're making changes. You know, they have the general flight track they're planning on flying, but they'll make more adjustments in order to focus on areas of scientific interest. And so they you know, usually will fly at different altitudes. They might be down around 8,000 feet. They might be as high as 13 or even 20,000 feet, depending upon what they're looking at and what scientists are studying on that day's mission. So there's a bit more variability there as they conduct their science mission. And then our final aircraft is the G4 aircraft. Remember I said that they don't fly through the storm. They fly around and ahead of the storm. And so this flight track is a very good example of that. So we have the I think we can pick out what was the around the storm. There it is right here. And this, by the way, was a storm that affected Hawaii. And then you see that they do this kind of zigzaggy pattern up ahead of the storm. Well, the reason they're doing that is that the storm was moving in this general direction. So they wanted to know what the upper level winds and how strong the high pressure was to the north of the storm, because that would have a big impact on whether the storm was going to continue to the northwest and impact Hawaii, or if the ridge was strong here, if the high pressure was staying strong up here, it would act as sort of a wall and force the storm to turn more westward and go south of the island. So it's not just important to find out what's going on inside the storm. Oftentimes, many times, it is very important to know what is happening around and ahead of the storm to have a better idea, because just like a piece of wood floats in a river, so too does a hurricane float in the overall airflow that are the winds that are moving around the planet on a day-to-day basis every day. So those are the 3 kinds of basic missions that we fly. Let's talk about what we collect while we're out there. So there's a variety of meteorological parameters that we collect while we're out in the storm. One thing we collect definitely is the storm position. We try to find that exact center of circulation and mark that as the center of the storm so that people can, on the ground, the forecasters can know as time progresses how that storm is moving. They want to know the winds at the flight level. We collect that, where the aircraft is flying. Like I said, the Air Force typically flies at about 10,000 feet in strong storms, and NOAA may vary somewhere between 8 and 13,000 feet. The winds at the surface, of course, are important because, hey, people don't live up at 10,000 feet. They live down at the surface. So we collect winds at the surface, and I'll show you a bit about how we do that here coming up. Temperature and humidity are also important. We collect that from the planes and also using instruments to get down to the surface, and also the rain rate, how much rain is falling at any given time in any one spot. From the planes, we can extrapolate using some mathematical calculations, knowing what we have at the planes, we can extrapolate the sea level pressure down at the surface, and we will also get the exact sea level pressure at the surface at certain spots. Radar, of course, is a very, very important part of what we're doing here, and we have, the Air Force has a single forward-looking radar, Doppler radar, whereas the NOAA hurricane hunters, you might have noticed on that picture that there was kind of a belly pod hanging underneath the P3. That's an extra radar that they have, and both the NOAA aircraft also have radars in their tails. So they have much more sophisticated radar suites, which they can look at the storm in many different frequencies and various cuts of the storm to get better idea of what's happening both in the horizontal and the vertical. And then finally, we have human observations. Yes, the good old, as we called it in the military, the Mark I eyeball. And so the sensing of the humans is still important out there. They can get a read on how turbulent the flight is. And I'll tell you, there are times there it can get pretty darn turbulent. There have been a few times where things have gotten really bad for me, and I'll be talking about that a little bit in my There I Was segment. Also looking at the lightning in the storm and also just general impressions of what's happening. One thing we can use for our Mark I eyeball is to determine surface winds. So you're looking down at the sea surface and you see this. You might say, okay, how strong are those winds? Well, what we do is we actually have a picture book, yes, a literal picture book that has been developed over decades of experience that says if you see certain features on the sea surface, if you're at a certain altitude, you can estimate the surface winds based upon those features. So things we look at are stuff like, how big are the foam patches here? Are the foam patches white, or is there a lot of green mixed in with those foam patches? How strong are the white caps? How visible are the white caps that are running perpendicular to the wind? And how long are the streaks that are running parallel to the wind? So looking at all of this and comparing to our picture book based upon our altitude, we would say this is about 80 knots, so a little over 90 miles an hour, the winds. Now, of course, this works well enough for how it does. You know, like I said, decades of experience doing this, but there's a couple of different limitations to this. One limitation, of course, is, hey, this is daytime. At nighttime, the Mark I eyeball isn't so good at seeing the surface of the ocean at night. And then the problem number two is that oftentimes we don't have a clear view of the ocean surface. There's clouds between us and there, so we can't see it. So of course this presents
Warren,
a bit of a problem.
let me jump in. If you mentioned green, is there a difference? Is it stronger when there's green, or is it if it's all white?
Yes. Because what's happening there is if, as the wind is blowing across the water, if it's churning the water more, you're actually getting air that's getting pushed down deeper into the water. You're kind of creating almost an air-sea mixture, and that takes on a definite greenish tint. So the like this white cap here, this patch of foam here, that's mostly surface foam. And so that I mean, there has to be a certain amount of wind speed to generate enough turbulence to cause that water to foam like that. But when you start seeing the green patches, like in here and perhaps up here, that's saying that the foam is getting kind of mixed down into that first couple of feet of the ocean. And so from our perception, we're kind of looking at that white through a couple of feet of ocean. And so that adds that greenish tint. So that shows us that as we're starting to see more greenish tinting to the surface of the ocean, that the winds are getting stronger. In fact, when you see the winds getting up over 120, 130 knots, pretty much the entire surface of the ocean takes on this kind of weird greenish white tint, as almost the first foot or two of the ocean is just churned into this almost air-sea mixture. So that's how we
appreciate that.
Yeah. No problem at all. No problem at all. So that's how we would use our eyeballs to do it. But now we have some technology to help us out. And this is called the Stepped Frequency Microwave Radiometer. There's a mouthful for you. Military loves its acronyms, certainly. And what this is a little pod that is attached to the wing of the C-130. And this little white spot here, this is a passive receiver. It's not sending out any radiation, but it's a microwave receiver. So it's kind of like an eyeball that can see in microwave wavelengths, which are shorter than visible light wavelengths. And it can actually see in 6 different microwave frequencies. And it turns out that microwaves are bombarding the surface of the ocean day and night. It's not just during daytime, also at nighttime, and they're bouncing off the surface of the ocean. And depending upon how strong the wind is blowing across the surface and churning it up like you saw in the previous picture, it changes how much the microwaves reflect and at what angles they reflect. And it differs for those 6 different frequencies. So the computer that's connected to this receiver is watching those microwaves scattering up from the surface of the ocean, and through some very complicated mathematics, they can actually develop an estimate of how strong the winds would have to be blowing across the sea surface in order to cause that particular pattern of scattering and strength of scattering. So the advantage of the SFMR is that it doesn't care about whether it's day or night, and that scattering microwaves pass right through clouds, so it also doesn't care if there are clouds between it and the surface. So using the SFMR, we can now estimate the surface winds no matter what time of the day, and the weather officers don't have to be looking out the window seeing if they can see that surface of the ocean. So that's very, very valuable information that has made a huge difference to the ability of forecasters to figure out what's happening currently with a storm to help improve their forecast for what will happen later on. So that is one way we can get surface data, by staring at the microwaves bouncing off. But we also want to get some other information about the surface, like, for example, the pressures down there and what temperatures and humidities are. And for that, we use a drop sonde. A drop sonde is a small little package of instruments. It's about the size of a mailing tube, maybe 4 inches across and maybe 18 inches long, and it's packed with scientific instruments. It's got a temperature and humidity sensor in the bottom, down in that white spot, white area down here. Inside this white area, there's a little sensor for temperature and humidity. Inside the tube, there's a barometer for measuring atmospheric pressure. And then there's also a GPS receiver in here, just like you would find in any kind of smartphone these days. And 4 times a second, as it's falling with this little parachute, it's ejected out of the bottom of the aircraft, and it floats down at somewhere between 1,000 and 2,000 feet a minute. And as it's floating down, if you remember the old Dr. Seuss story, Horton Hears a Who? Well, as it's falling 4 times a second, it's calling out, "I'm here, I'm here, I'm here," and radioing that back along with the temperature, humidity, and barometric pressure to the plane. And the computer on board the plane can take all those "I'm here's" and translate those into wind speeds and directions that the winds would have to be blowing to move the drop sonde along that particular path. So that's how we get that information about what's happening from the aircraft all the way down to the surface. Now, once that information comes in, and also all of the data from the plane, all of that data is packaged up and beamed up to a satellite that's 23,000 miles up in the sky, geosynchronous orbit, and then beamed down to my office in the Hurricane Center, where we look at it, we take a look at how it compares to all the other data that we have available to make sure it's good data, and then we get it across to the Hurricane Center forecasters, who are literally right across the hall from my office in the Hurricane Center, and we also send it out to the rest of the world. So that's kind of a broad overview of the mission that we do. So we've now entered that portion of the presentation that I refer to as "There I Was," a few stories to tell. So I've been fortunate in my career. Some would say fortunate is an interesting term, but that's what I like to think of it as a weather geek, to have flown into some pretty amazing storms during my time of flying into storms. So I wanted to bring a couple of anecdotes to tell you what it was like and some pictures. So the first one, this is Hurricane Ivan. This is back in 2004. Ivan was a very strong storm right about there. It's a Category 5 storm off the western coast of Cuba, between roughly Cuba and the Yucatan Peninsula. This came in and smashed into Alabama not too many days after this, and then actually went all the way up. The remnants of it came back across Florida. It was declared Ivan again and finally made a landfall in Cameron, Louisiana, a couple of weeks after this picture was taken, so a fairly long-lasting system. But what was interesting about this flight for me was that it was my first Category 5 storm. And remember one of the pre-questions we had, what are storms measured against? Well, it's category 5 on the Saffir-Simpson scale. That is the scale that is used to judge hurricanes on a 1 to 5 basis. And that's dependent upon such things as wind speed and central pressure, and the lower being the more intense, and also several other parameters. For those of you who had answered the Fujita scale, well, that is used to measure tornado strength. And so, same kind of, judging, they both rate on a 1 to 5 scale, though tornadoes actually, there's an F0 for tornadoes. There's no category 0 hurricane on the Saffir-Simpson. But for hurricanes, they measure them on the Saffir-Simpson scale. So this was my first category 5 storm. And so that was real interesting because, I'd never flown a category 5 storm. And it wasn't too bad. It wasn't that rough. I'd like to use the analogy of a fish in the river. For those of you who have ever seen Finding Dory, if you remember the scene where Dory and his dad got with the turtle and they rode that current most of the way down to Sydney, well, imagine that current is like a hurricane where the winds are that current flowing through. So if the current is flowing smoothly, like it was for most of his journey, he didn't know he was going fast. He may have looked down, if you could see the bottom, saying, wow, that bottom's going by fast, but didn't realize it himself, but then let the current go over some rougher surface and get turbulent, well, then you really feel it. So Ivan wasn't, as I recall, a particularly violent storm in terms of turbulence bouncing around. But there were a couple of other interesting things about it. One of those things was to get to Ivan, we flew over Cuba. Now, you can't really see it because it was kind of hiding. You can see a little bit of right here, but it kind of stretched over here. Here's the western end of Cuba right here. Now, normally, U.S. military aircraft don't really go over Cuba and haven't for about, what is it now, 60 years or so? But this is an answer to, we have 2 trivia questions for you here. I'm giving you the answers so you can amaze and surprise your friends with your meteorological knowledge of hurricanes. So the first question is, what is the only U.S. military aircraft that is allowed to fly over Cuba? And the answer, as I can speak from experience, is an Air Force Hurricane Hunter aircraft with approved clearance. So what that means is that if we see that there's going to be a storm that's going to be impacting close to Cuba, we here at the Hurricane Center can make a request and route it through the proper diplomatic channels to the Cuban government and say, hey, we need to get a Hurricane Hunter aircraft in there to get more information about the storm to better forecast what it's going to do. And let's face it, hurricanes are going to impact Cuba just as much as they're going to impact the U.S. So it's to their benefit to have more information, have a more accurate forecast. So almost all the time, they will come back and they will say, yes, you, Mr. Hurricane Hunter aircraft, are allowed to fly into our airspace, even though you are a U.S. military aircraft. So that has happened on occasion, and we still do that to this day. And it's a little bit of cooperation that really is one of the hallmarks of meteorological science, is that in order to gather data, the weather doesn't care about political boundaries. It happens regardless. So in order to better understand the world, you need to really be able to collect data from everywhere. So it behooves meteorologists to try to do what they can to collaborate when possible to get a better picture of what's happening in the weather worldwide. So that was the first interesting thing about this storm, my first trivia question. The second interesting thing of this storm actually happened when I first got to the squadron that evening. It was a night flight that I took in order to actually go on the flight. Now, we, of course, are a military unit. We do sometimes carry some media aboard to show them what it's like in the storms. You've probably seen various clips of stuff on news shows or science websites about what it's like inside a hurricane. Well, when I walked into the briefing room that night, I saw a face that looked familiar to me. It was this face. And it's like, wait a second, what's going on here? Because those of you who are older, I grew up, in the 70s and in the early 80s when I was in college, and this was a familiar face on movie screens. This is John Cusack. He was an actor known in his younger days for movies like Better Off Dead and also The Sure Thing. And then later on, he moved as an adult. He moved into doing more adult films, not that kind of adult, but more grown-up films. And he was doing research on a movie, and somehow he had convinced people high up in the Air Force to let him get on board the aircraft. If you've ever seen the movie 2012, yeah, you know, there's a lot of stuff about weather and climate in there. Well, and we won't get into the accuracy or lack thereof of that movie, but the important thing was he was doing research to get ready for that movie, and he wanted to see what it was like inside of a hurricane. So that brings us to our second trivia question to amaze and wow your friends. What Hollywood star has flown through a Category 5 hurricane? And there's your answer, John Cusack, yes. So that was Hurricane Ivan in 2004. Let's turn our attention now to a year later, Hurricane Rita, 2005. 2005 was the year where storms just never seemed to end. That was the year they ran out of names and had to go to the Greek alphabet to name the storms that happened late in the season after they got past, I believe Hurricane Wilma was the last one. But wow, what a season it was. This season saw some not so great stuff for the 53rd Weather Reconnaissance Squadron. Hurricane Katrina devastated their base at Keesler Air Force Base, Mississippi, and for a few months we were actually flying out of Dobbins Air Reserve Base, near where I was living in the Atlanta area at the time. So it was from Dobbins that I actually took off on this mission into Hurricane Rita back on late September. This was actually, I think, my mission was a couple of days before this, but it was another Category 5 storm, a monster in the Central Gulf. Now, one thing about hurricanes is that you think thunderstorms, you think lightning all the time. Well, hurricanes don't have as much lightning as you would think, because the freezing level is so high in these storms that the ice crystals form only at the very tops of the storms, and so it's kind of hard to get the charge separation that would lead to a lot of lightning. But if a storm is very strong and intensifying, you can see a lot of lightning. And that was kind of what I was seeing. Again, it was a night flight. I seem to get the night flights a lot, which is not too bad because I'm a night person anyway. So we were flying into this thing. We were coming in for our first pass. And this was one of the results of Katrina devastating our base at Keesler, was that we were supposed to, in 2005, be switching gradually over from flying the C-130H model to the C-130J model. Well, Katrina said, well, nothing doing with that. When we had to evacuate for Katrina, all of the H models were sent to Houston, and the decision was made to send all of the J models and all of the personnel up to Georgia. So we had to make a very quick and rapid transition over to the J model. Now, one difference between the H and the J models are that in the H models, the weather officer sits up on the flight deck and can see out the front windows. In the J model, the weather officer sits down in the cargo bay and can only see out a side window. Rita was one of those where I kind of missed being in the H model, because as we were flying through that first pass, starting to punch through the eye wall that first time into the center, it was, by contrast to, say, Ivan, it was a very rough flight. It was really, we were being bounced around a lot of very strong jars as the bottom would drop out of the aircraft and then bounce back up again. And then I was seeing a fair amount of lightning out the side of my window, looking out the side of the aircraft. So eventually, I could feel the winds were starting to go down. I could see that in my instruments, and we broke into the eye wall. Now, usually, it's pilots get the first look at it, and it's just they've seen a lot. Well, on this particular night, the first words out of the pilot's mouth when we broke into that eye wall were wholly not repeatable on a family YouTube video or other type of recorded video. And the reason the pilot was so surprised at what he was seeing was that in most big storms, remember I showed you that picture of Dorian a few slides back where it was kind of bowl-shaped, the stadium effect? Well, in Rita, the storm was so strong that the eye wall was a vertical pipe, 16 miles wide, and the walls of the eye wall were completely vertical. And so with that, you also had, remember the lightning I mentioned? Lightning, he was seeing arcs of lightning starting off, say, his left wing, and then rippling across the front of the eye wall, and finally finishing up off his right wing. So it was like almost being inside of a human brain and seeing the electrical signals just arcing back and forth all around this place. And then if you stuck your head up against the side of the cockpit window and looked up, you could see that curve of the eye wall, and there was just black sky above you with stars winking down at you. So a very, very impressive storm indeed. And we've got inside and we dropped a drop zone down in the middle of it to get that central surface pressure. It was down to 895 millibars. So that is one of the strongest storms. It's very rare for hurricanes anywhere in the world, but especially in Atlantic, to get down below 900 millibars on the central pressure. So getting it down to 895 marked Rita as one of the strongest storms on record in the Atlantic basin, even stronger than Dorian in terms of central pressure. About a couple of days after this is when Rita hit along the Texas-Louisiana border and unfortunately caused a fair amount of destruction and unfortunately also some deaths. So that was Hurricane Rita. Now we're going to advance to the other side of the world. This is 2010. Now, back prior to the early 90s, there was a separate squadron, the 54th Weather Reconnaissance Squadron, that was based in Guam, whose responsibility was to fly Pacific typhoons. Due to some budget cuts and changes in thinking, they decided to close that squadron in the early 90s. And usually, since then, we have not had aircraft reconnaissance in the Western Pacific. But in 2010, we had a research project pop up that requested, and most importantly funded, the ability for several Hurricane Hunter aircraft to go back to Guam to fly into storms. And Super Typhoon Meggy was one that I got to fly here before it made landfall. And this blue cyan outline you see here, that's actually the coast of the Philippines. And this storm smashed in as a very strong Category 5, and again, unfortunately, caused a huge amount of destruction and death. When I flew it, it was back over here, just off the right side of your picture, and just notice how symmetrical the eye is here. Well, again, remember earlier I showed you satellite picture of Dorian versus interior picture of Dorian? Well, let's go from satellite picture of Meggy to interior movie of Meggy. So this was the flight before I went on. Yeah, you guessed it, I got the night flight. So this was the day flight before, and what we're looking at here, the plane is inside that eye you just saw on satellite, about 20 miles wide, and boy, can you see the stadium effect here. The thunderstorms just rising in a single mass ring around the plane. Now it'll tilt, the camera will tilt up here in a moment, and you'll be able to really see just how curved that edge of the eye wall is. There it is there. Look at that, little tufts of cirrus clouds extending in, but notice the brilliant blue sky is up above, perfectly clear above this eye, and just right next to it, a mass of extremely strong thunderstorms. Now, you've certainly, as weather people interested in the weather, you've seen weather radars on TV, the greens, the yellows, the oranges, the reds when it's bad. Well, we need about 4 shades of red on our radar. From, okay, you can go there, to no, don't go there. This is what it looks like on the radar inside of a big Category 5 typhoon. So we've got the reds, but then we've got the magentas, and then we've got the non-flashing whites, and then you've got the flashing whites for, oh no, don't go there. That's where the extreme turbulence is. 10,000 feet, and again, there's the surface of the ocean. So you can see, again, those big patches of white, and even from this angle, you can see some of those patches were kind of a greenish white. The top winds in this storm were up over close to 200 miles an hour at flight level, and not far from it at the surface. And when I was in it shortly after and dropped a sonde in the middle, well, we got it down to 890 millibars, I believe. So very rare again. So again, one of the strongest storm on record in the Pacific, getting down under 900 millibars. The record, by the way, is 870 millibars, and that was set in Super Typhoon Tip, and I believe 1979. So that was my experience flying out in Typhoon Meggy, getting a rare chance to go out into the Western Pacific. And my final one, now you look at this picture, say, wait a second, you've been showing me these massive Category 5 storms, 3 in a row. This picture doesn't look like anything. And you'd be right on that, but you'd be surprised. Say hello to Tropical Storm Gabrielle, 2001. A little story behind this one, too. The first time I was supposed to fly into this storm, September 11th, 2001. I was prepping for the flight when we heard that the first plane had hit the World Trade Center. We saw the second plane hit as we watched on TV, and then the airspace nationwide was shut down. So our mission was canceled, and we were locked in at Keesler Air Force Base for the next several days. Now, a couple of days later, the storm had continued to move further to the north and was beginning to become a concern for the west coast of Florida. So the decision was made and the appropriate permissions were given so that we would be able to get special permission to fly out into the storm, even though the airspace was still shut down. So we took off, and as you might guess, it was a night flight, and we headed out into the Gulf of Mexico from Keesler. Now, most of the time when we fly, especially over the Gulf of Mexico, we hear just an enormous amount of talk over the radios between air traffic control and planes flying to and fro across the Gulf, heading down into Central America and heading to South America. On this night, though, the radios were dead quiet. It was the spookiest sound I had ever not heard, except every so often we would hear a little blunk, blunk, a little snippet. Couldn't even make out any words or anything, just a little blap, blap, blap. And it took us a little while to figure out what it was. And then it hit me. The fighter pilots that were patrolling the skies, the F-15s and F-16 that were patrolling the skies well above us, because we were down at about 5,000 feet at the time, and they were up at probably 35, 40. They were using what are called frequency hopping radios, where they hear their entire conversation, but the radios are actually flipping between frequencies so that no one else can listen in. And so we were hearing that little bit of conversation, that little syllable or two, as they were hitting our frequency and skipping on to the next one. So again, not something we were used to hearing at all compared to our usual air traffic control. Now, mind you, we were just to the west of Tampa, which is the home of U.S. Central Command. So I got on the intercom and it's like, pilot, weather. We do have our identification friend and foe codes loaded, right? And he confirmed we did, because the last thing we wanted was for some fighter pilot to decide, see a low-level target flying off the coast of Florida and not know what it was and decide to shoot first and ask questions later. So fortunately, because I'm here today, obviously that didn't happen, but still it was a bit of a concern, not the usual thing you worry about when flying storms. So that was the prelude to the storm. The storm itself, again, it didn't look like much on radar. It didn't look like much on satellite. But I have to say, it was the worst beating I ever took in all my years of flying. There were times going through that storm where the plane was shaking so violently and dropping so quickly and rising so quickly that I could not read my instruments for a good 30 seconds at a time, because my body, of course, was strapped to the aircraft, so it was shaking with the aircraft. My eyes, though, were floating around in my eye sockets and just weren't able to keep up looking at the instruments. So, at that point, we weren't flying the aircraft. We were just waiting for Mother Nature to hand it back to us. It was trying to become a hurricane, and it ran out of time before it hit the West Coast. It hit as a strong tropical storm. But boy, I will always remember that as the most violent flight I ever got, which just goes to show it isn't necessarily the strongest storm that causes you the most grief. Often it's a storm that's interacting with land or trying to become a hurricane, trying to strengthen, that will really come up and bite you. So you can't say there's ever an easy storm. You always have to be ready to deal with the worst, even if the storm doesn't look all that big. All right, so like I said at the start, I'm a military briefer. So I've told you what I was going to tell you. I just told you all of it, and now I'm going to tell you what I told you. So we've answered a few questions. If any of you are into journalism, there's the standard questions that have to be answered in any story. So we've answered the when question. When did we start flying in hurricanes? Answered the what question. What planes have been used? The who question. Who does it? The 53rd and the NOAA AOC. The how question. We talked about how we coordinate the missions and then go out and fly them. And we also talked about the where mission. We fly them in the Atlantic and the Pacific Oceans. But that leaves one question, the big one. Why? Why do we still send men and women? And yes, there are a lot of women flying this mission. If there's any girls out there who are interested in the weather, a lot of women that are in both squadrons that are flying out into these storms. Why do we send these men and women out in the storm when we have all of this wonderful remote sensing technology, satellites, radars, and this and that? Why do we still do it? Well, why we fly. We do it because some data can only be obtained from inside the storm, inside the belly of the beast. So for an analogy, I'd like to imagine that you go to the doctor, and the doctor says, we're going to do a chest x-ray just to check up on you. That's great. That's a satellite picture. It gets you a lot of good information, but it's from external and on high, as it were, so it can't pick up anything. So now hopefully the doctor never does this, but let's say the doctor looks at the chest x-ray and says, I don't like that spot right there. I want to get more information about it. I want to do a biopsy. Well, those planes I showed you earlier, they're hurricane biopsy tools. They're able to get inside the storm and measure directly from inside of the storm that exact information about what's happening, and that can be critical in helping the forecasters determine whether they're dealing with a Category 4 storm or a Category 5 storm, or whether it's turning or if it's still barreling toward a major city. So that's one reason we go inside the storm. And that's the second reason. It improves forecasts. It's been shown that our data improves forecasts by somewhere between 10 and 25%. So instead of a cone of uncertainty, you've probably all seen those cones on the Hurricane Center products and on TV, instead of it being a wide cone, our data maybe helps narrow that down. And by narrowing it down, that means that hopefully, people who need to get out will know, and perhaps people on the outside edges won't have to go and clog up the roads because hopefully they will be out of the forecast area. Mentioned how NOAA goes in and conducts a lot of science. Well, that research increases scientific knowledge. So knowing how these storms work, again, improves the forecasting techniques. It improves the computer models that we rely on these days to look into the future and figure out where those storms are going to go. So by getting that exact data about the internal structure and the internal processes of the storm, that's more that we can program into the computers to simulate how these storms will go in the future and help in future forecasting. And at the end of the day, Hurricane Hunter data saves lives, because that's really what it's all about. That's why we spend the money. That's why we invest in the training. That's why we still do this, because the information we provide helps forecasters be more accurate, which means that, say, emergency managers can more closely tailor their evacuation orders. And in the end, hopefully people will listen to those orders and get out. Meteorologists live the story of the boy who cried wolf every day. They want to make the most accurate forecast possible, knowing that Mother Nature is always going to try and deny them that capability. Any meteorologist who tells you they can make a 100% perfect forecast and do it repeatedly is either lying to you or they're delusional, because Mother Nature will quickly humble you and throw a curveball at you, and the forecast that you thought was so certain suddenly isn't so certain. I'm going to finish on a couple of pictures here. Remember I talked about flying into Hurricane Ike and how wide the wind field was? Well, those winds were blowing across the Gulf of Mexico waters and just piling them up, especially on the right side of the storm in relation to its track as it was heading toward Texas, and sending that water in toward the coast of Texas. Left-hand picture is, of course, the before picture. The right-hand picture is the after picture. Not much left. That was in 2008. Another one, Hurricane Michael, more recent, 2018. This is Mexico Beach in Florida in the Panhandle. Top picture is the before. The bottom picture is after, as Michael slammed ashore as a Category 5 hurricane, and just the storm surge demolished so many things. And that's why we do it, really, in the end, because sadly, we know there were people in some of those houses that did not make it out after the storm. And I imagine that poor person sitting there as debris is flying all around the house, and now the storm surge is rolling in, and they can see it, they can maybe hear it over the scream of the wind, and they're thinking, I should have listened, I should have got out, and now it's too late. The men and women of the 53rd Weather Recon and NOAA Hurricane Hunters go out into the storms and put their lives at risk. And we do everything we can to minimize that risk, of course, but it's still there. They do it to help the citizens of the U.S. and many other countries affected by hurricanes make good decisions to protect themselves, their families, and their properties from storms, to protect them from risk. That's why we do it, and that's why I'm proud to have served with them and to continue working with them here as part of my role in coordinating all the flights. So thank you all for your patience and listening in on me. Again, I'm Warren Madden. I'm the Chief of Area Reconnaissance Coordination, all hurricanes. There's my Twitter handle. And if you want to take a look at some of the data we send out, and we send it out all the time during storm season, there's the web link for it. I'll conclude my presentation right now and let Henry open it back up for questions.
Thanks, Warren. Great presentation. We just really appreciate you taking the time out of your day to be with us today, and just a lot of stuff folks don't know about hurricane hunters. Well, and we'll put this link up on our website too. We'll have a specific page for that. We have with us actually on the web today students, a good student section here from Open School East in Portland, Oregon. I want to give those guys a shout out, and they've got some questions. And also we've got other folks. So if you have a question, go ahead and type it in now. We'll try to. We got about 20 minutes. Will that work for you, Warren?
Yeah, that works for me. Now,
okay.
I will say I don't know if I've got my setup right here, but I'm not seeing the chat. Is there anything I need to do, or will you read the questions?
I'll just ask them to you. I'll just ask you the questions as they come in, and we'll go with that. So, and the ones that we don't get to, we'll try to follow up afterwards for you. So, Tommy from Virginia wants to know, have you ever seen red sprite lightning when you've been on any of these hurricane hunters?
Good question. Good question. I cannot say that I have seen it myself, but actually I'm not very surprised at that, because remember, we fly down at 10,000 feet. So that's not all that high in contrast to the red sprite lightning that, if I recall correctly, typically forms off the top of thunderheads and would more energize off into space. So that is well above the altitude at which we are flying. And so I'm more focused on what's happening below me, to be perfectly honest, than what's happening above me in these cases.
Okay, so here's some from the students, and I'm going to read a couple of them, but we'll go in sequence here of what we've got. They were interested in how do you become a hurricane hunter? How do you do it for a student? What would their career path be to do something like that? All
righty. Well, let's see. My case, I was very lucky. I kind of fell into it. I've always said that, you can't make opportunity knock, but through preparation, you can at least put the welcome mat out. And so what I would suggest, if you're interested in becoming a hurricane hunter, first and foremost, do well in school, and especially math and science, because those are the foundations of a meteorologist's preparation. Meteorology is an interesting career field because it's, in a sense, half science and half almost arcane art, as it were, because forecasting, you have to have a good feel for how the atmosphere is working, and that helps you make a good forecast, but also the underlying physics of it all are very heavily in math and science. So do well in math and science in school. And then certainly look for, if you want to advance into meteorology, there are many fine schools out there that have meteorology degrees. In terms of actually becoming a hurricane hunter, I'll speak to it more from the Air Force perspective because that's the one I'm most familiar with. So as I mentioned, the 53rd is part of the Air Force Reserve. So, and we are based out of Keesler Air Force Base, Mississippi. So there are both officers and also enlisted people who fly. The officers are the pilots and the navigators and the weather officers. So if you're interested in becoming a weather officer like I was, I would say definitely look at getting a meteorology degree. Perhaps think about maybe starting off in the Air Force as an active duty Air Force person. Perhaps, one of the way I paid for school, my first degree was an Air Force ROTC scholarship. So that might be one possibility. Or if you are looking to do it perhaps afterwards, get your degree, and then you could go to officer training school and become part of the Air Force Reserve. And then also if you're looking at it from the terms of the enlisted side, remember I showed you the drop-sons? Well, the folks who deal with actually sending those drop-sons out and getting all the information, coding it up properly, those are actually enlisted people, sergeants. And so again, part of it would be joining the Air Force Reserve and then going in that direction, talking with your recruiter and talking with the squadron and seeing what openings they have. So that's kind of the path you're looking at. But certainly if I'm speaking to students about it at the high school or below level, my first emphasis would be to do well in math and science because that is the foundation for any real career in meteorology.
Great. Here's one from Dale, and he wants to know, do you usually fill the tanks to the max or not on a plane like this?
It will typically depend upon the mission profile. So our aircraft are not air refuelable. So our mission duration, our max tank limit is about 13 hours, I think would be our absolute absolute max. Typical missions will last somewhere between 8 and 10 hours. And obviously we'll want to carry reserve because, again, hundreds of miles from any land, you want to have options, and the fuel that you leave back at the base does not give you options. So typically we will carry a fairly full fuel load. Interesting, the difference between, again, my experience in the Air Force, the H model, the engines we had on that were not nearly as efficient as the modern engines, and so to manage our mission we had to have a big extra fuel tank in the cargo bay that would carry thousands of gallons of extra fuel. With the J model, the engines and new propellers are so efficient we were able to completely get rid of that internal fuel tank and still have the same duration, endurance on station. So yeah, we typically will fill up just about all the way because, again, options.
Thanks. Here's one from Michael. Wants to know, have you ever seen anything in a storm that you've had no explanation for or could not explain?
I wouldn't say I have personally. Are there things that we don't completely understand about storms? Certainly, and that's one of the reasons that especially the P3s go in, is to study them. My goal as far as my job going in was fairly focused, shall we say. My job was to go in, it was to find that exact center of circulation and to collect data about what was going on in the eye and also in the eye wall around. So given that my focus was on those very specific pieces of information, I wasn't necessarily looking for phenomena that would be hard to explain. Everything, it's such a busy time in there that you pretty much have time enough just to do your job and just not really do much else. So in that sense, no, I don't think I've ever seen anything that I could say, what's that all about? I was more just like, I got to get this data because the forecasters are relying on me. So that's kind of what I was focused on.
Here's a couple of questions from the students. I'm going to try to combine these all into one question. Their question is, on a scale of 1 to 10, how dangerous is the job? Have you ever experienced technical difficulties while flying into the storm? And one that I've heard students ask before, have any of the planes, has anybody ever died on these missions?
Okay, well, let's deal with question one, that last one first. Unfortunately, yes, we have lost a few aircraft. I believe the total that we've lost actually in the storm environment, I believe, is 6. Now, fortunately, and if anyone's superstitious, find some wood, start knocking, we have not lost an aircraft since 1974. And that was in it was one of those earlier WC models, like the picture I showed you in the history section, the H model, and that was lost in Typhoon Bess in the South Pacific, South China Sea, actually. And to this day, we don't know what happened. This was in the day before satellite communications, so it was all high-frequency radio, and they radioed back 1 hour saying, hey, everything's fine, we'll talk to you next hour, and then they never did. And the search and rescue people found a bit of debris, but we still don't know what happened. There was also a Navy flight, one of those P-2 Neptunes I showed you, that was lost in Hurricane Janet in the Atlantic. I think that's the last one we lost in the Atlantic. So unfortunately, this, like I said, this mission is not without risk, but we do everything we can to minimize it. The maintainers are some of the best people in the world at maintaining C-130s. I was literally putting my life in their hands every time I flew, so I had to trust them and know that they were good. And then the crews, we train constantly to make sure that we understand our aircraft and the mission. We know where we can go and where we can't go. We're never going to put ourselves in a position where we feel we're not safe. That's just not in the cards. Aircraft and crew safety is the paramount importance. Scale of 1 to 10, that's a bit harder to judge, but I'd like to tell people that I was at more risk driving to Keesler from Atlanta down I-85 and I-65 and I-10 than I was actually out in the storm. It's just one of those things where you're never going to completely eliminate it. Any aircraft, flying aircraft into that kind of environment, there's going to be some risk, and you just have to accept that the gains are worth it. I told my wife, I said, if God forbid something happens out there, then you won't have a body to bury because I won't be coming back. And it's just, the goal of getting that information, it is so important that it makes it worth the risk.
Thanks, Warren. Here's a couple more questions. Actually, a couple on this about the dropsondes. And here's one from Charles. I'm going to combine it with Tommy's question. Do your sondes gather any acoustic data? And the other question was, do you guys use biodegradable dropsondes since they go into the ocean?
Interesting questions. I'll deal with the second one first. So we do try to at least make as much as we can of the sonde biodegradable. The outer shell is primarily just cardboard, so that of course will biodegrade. The internal circuit board and some of the instruments, and there's a little bit of plastic housing that of course is not biodegradable, but we do what we can because there's no way to recover them. You saw the pictures of the ocean. I'm not going down fetching them, and every once in a while one will drift onto land. If we're flying close to an island or close to a coastline, the winds may carry it on land, we may get it back, but the vast majority of them we do not get back. So we try what we can to make them biodegradable, but within the limits we do, but there are limits. The first question regarding acoustic data, the sondes are not designed to do acoustic gathering. They're primarily just meteorological parameters. Now, that being said, there are times where we will be running submissions where we actually will drop what are called AXBTs, which are in fact old Navy sonobuoys that were used again for hunting submarines. We use these to determine what's happening down under the sea in terms of temperature profile, because how much warm water is there close to the surface that's actually the fuel for the hurricanes, that warm surface water. Now, they were originally designed to have sonar in it in order to try and detect submarines, but to the best of my knowledge, they do not collect that information anymore. Sound not really a factor in the meteorological calculations that we use.
Okay, great. Here's one here. What is the title? This is from Gabrielle. What is the title of people on the ground who aren't in the plane? Do they have a specific title?
Let's see. I'm not overly specific. I mean, we do have many people who are on the ground in the support roles at the squad, both squadrons. I don't know, and they probably have specific job titles that would be, so like there's maintenance technicians. There's we have all sorts of people. Like any organization. So we have people who are travel specialists, because of course when we have to deploy, we have to, like any government bureaucracy, you've got to have the authorization to travel, and you've got to get people paid travel pays and make reservations at hotels. So we have people who are specific to that. So just like any large organization, we have various people with those functions, and their title might reflect that function, but there's not one general title. From the standpoint of the squadron, we are all hurricane hunters because we're all involved in the mission, whether or not we're actually out in the storm or we are on the ground supporting that. We all have the patch on our shoulders that says, Hurricane Hunters, 53rd Weather Reconnaissance Squadron, or NOAA Hurricane Hunters.
Sergio wants to know, he's wondering, since hurricanes have been around for a long time, in the last 30 years or so, has climate change had an effect on their intensity? And the other question he wants to know, are there any preventive measures that are used to mitigate the hurricanes? So 2 questions here.
Okay. Well, I knew eventually the climate change question would show up. And on this one, I'm afraid I'm going to have to defer a little bit. Our job as hurricane hunters is much more about gathering the data and not interpreting how the data is changing over time. I mean, there's definitely, that is an area of intense research and still some disagreement on the effects. I mean, some of the things that play into that are, increased sea surface temperatures. Again, I mentioned that hurricanes feed off of that warm ocean water. So if oceans tend to warm up a bit, that may tend to increase hurricane strength. There's a couple of different ways of measuring this too. You're talking about more hurricanes necessarily, or do individual hurricanes on average, are they stronger? All I'll say on it is that there's a lot of very active research going on, and that's, I would say, look at work, say, of Kerry Emanuel at MIT. He's done a lot of research on this. That might be a good starting point to look at some of his papers to see what he's coming up with. But in terms terms of the actual research side, that's not our bailiwick. We're more about gathering the data so that researchers can take that and then try and figure out those questions. And then on the second question, let me see here, now I'm trying to remember that. Oh yes, modification. All right, so there was a time where they actually considered trying to modify hurricanes. If you want to go back in the history books, it was called Project Storm Fury. And this was done during the 1960s, I believe. I know it ended in the 1960s. And they would take out planes and fly over hurricanes and drop silver iodide particles. And the idea was that those particles would act as condensation nuclei, so the rain, the water vapor would condense on it and rain out quickly and hopefully weaken the hurricane. Well, there is a bit of you have to consider though, when it comes to trying to modify hurricanes, the intent certainly is good. You don't want them to cause damage and destruction where they would otherwise have gone and done that. But if you change a hurricane, and let's say it was headed toward area B, and after you do what you do, be it dropping silver iodide or some other thing, it goes and turns, say, or it affects area A and causes heavy rains, causes flooding or high winds or storm surge or whatever. Well, how do you choose which one gets affected? You know, can you control that? So that's one thing. And then the second thing is, if you were able to weaken hurricanes and dissipate them, well, there's a reason hurricanes exist in the greater Earth atmospheric system. Mother Nature, to use the generic term, uses hurricanes as one of the ways to move heat from the equator up toward the poles to keep things in balance, because the sun beats stronger on the equator than it does on the poles. So you have to keep things in balance, or else things just basically, like a top, it just fall over. So if you take away hurricanes as a tool for nature to move heat from south, from equator toward poles, nature's going to come up with a new way to do it, because it has to be done. And you might like that a whole lot less than even what hurricanes do. So weather modification can be a very tricky business. It might be best left undone.
Okay, we're going to take two more questions here, and then we'll call it a day for today. But John wants to know: have the use of drones or manned air vehicles been considered? Unmanned air vehicles, yeah.
Yes, excellent question. Excellent question. Yes, we are starting to make use of some unmanned vehicles in storm reconnaissance. A couple of different types. The first type I'll mention is the Global Hawk. That big drone that can fly up at 65,000 feet. It can actually go over the top of hurricanes. And just like you'd mow the lawn going back and forth across the lawn, we've had some missions in the research area of Global Hawk that fly over the top of the storm, go back and forth, just basically in line and shifting over, and drop 100 drop sondes out over the course of their mission over the storm. And that's good. It gets some interesting data over a wide area and some upper level data that we wouldn't get otherwise. But there are some limitations with this. Like I said, one of the very important pieces of information to know about a storm is how low the central pressure is, because that is really tells you how strong the storm is in terms of in comparison to other storms. And the lower the central pressure, typically the stronger the winds. So another analogy for you. I like my analogies here, I'm afraid. So let's say that I have a 5-gallon bucket, and I want you to drop a penny into that bucket. So I put the bucket right outside of a 30-story building, and I hand you that penny, and I send you all the way up to the roof, and I want you to lean over and drop that penny into the bucket. Well, odds are, unless you're very lucky, you aren't going to put that penny in the bucket. The winds are going to move it around a bit and just isn't going to happen. Now let's say that I give you another penny and I send you onto the balcony over the doorway on the second floor right above that bucket. You've got a much, much better chance of plopping that penny into the bucket. So the Global Hawk is actually that top of the building scenario, whereas Hurricane Hunter aircraft are down on that second floor balcony. So while Global Hawk can give us some good information, there's some things that it can't give us because it is just not in the right spot. The other type of drone that we're starting to explore are ones that are launched from aircraft from right inside the eye. And this has been done so far on the P3, and the idea being that they eject it out of the same tube that they eject sondes from. And then little wings pop out. And for those of you who are military historians, if you might remember the Alcom, the air-launched cruise missile, same kind of concept where it's launched as almost like a missile out, just punched off the bottom of the aircraft, and then the wings flip out, and a little tail pops up, and a propeller pops up. And then it can go down, and we've been using it to study what's happening down in the lower levels of the eye wall, where it would be too strong and too dangerous to send a manned aircraft down into. But here, too, there are some limitations so far. Naturally, because you have a limit on the size of the vehicle, because it has to go out through the same tube as a drop sond, there's a limit to how much battery space you have on it. And once you limit the battery power available, that also limits both the power available for it to fly, and it limits the power of the radios it can use to communicate. So that means the mothership has to stay fairly close by. So it's not like you could do this from shore, say. You still have to have an aircraft out there managing it. So the end result is that, yes, unmanned aircraft are gradually increasing in use on a research basis into how we deal with flying reconnaissance. The day may very well come sometime in the future where they can do everything that manned reconnaissance can do, and we will no longer need to send men and women out into the storm. That day, I don't think, I'm planning on retiring in about 10 or 11 years. I don't think I will see that day while I'm in my current job.
Here's another question from the students. They wanted to know, when you go through the eye wall, is it hard to control the plane? Does lightning ever harm the sensors or equipment on board? And finally, when do you decide to disengage, to say, all right, that's it, we're heading out of the storm?
Okay, all right, I'll take those one at a time. So first up, as far as controlling the aircraft, again, a lot of the time it's not as bad as you would think because you're moving with the air. I mean, we fly into storms that are, the strongest I've flown into was like a Rita or a Meggie, where the winds at the flight level where we're flying were close to 200 miles an hour. Now you might think, wow, that is just insane. No plane can fly it. Well, that was one of my other questions in the pre. You remember that was one of the questions in the pre-survey? If you have flown cross-country in a civilian jetliner, especially in the winter, you, my friend, have flown through winds of likely of at least Category 5 strength, because the jet stream way up high typically flows in the winter across the U.S. at between 150 and 200 miles an hour. That's why it takes so much longer to fly westbound than it does to fly eastbound. So it is possible to fly in those winds, and the pilots, certainly have the experience. Again, we train them by flying into storms to know how to deal with this. And so we look, and the navigator is looking at the radar, looking for, even though we've got that strong ring of thunderstorms, like you saw in the video of Meggie, they look for the weak spots so that we're not going through the strongest stuff. So that was the answer to the first question. The second question about lightning. If you've ever gone to one of those science museums that have the person who stands in the cage and he's got those big Van de Graaff generators that are just zapping, electrical bolts down at the cage. Well, a plane is kind of like the surface of that cage. The lightning may hit the plane and travel along the surface, but it actually doesn't penetrate inside. So my plane has been hit by lightning a couple of times. In fact, there was one time where it knocked out one of our HF radios, because that antenna, on a high frequency radio, the antenna tends to be a very long cable, and so the electricity did temporarily disable that, but there's a reason we carry two of them, so we have a backup. So lightning is not too much of an issue for us. There have been a few times where we've had radar lightning strikes that have affected our radar, and that definitely is a bigger deal, because you certainly don't want to be flying into a hurricane if the radar is not performing well. So if that happens, then we say, okay, time to go home. And so that brings us to our third question. When do we know enough is enough? Like I said earlier, the primary number one priority is aircraft and aircrew safety. So we're never going to go someplace that we don't feel safe. And I'll give you a case in point. Look, remember the last slide I showed you was Michael? Well, the interesting thing about Michael was that it was strengthening all the way up to landfall. It reached Category 5 strength as it was making landfall. And we know this because of the last aircraft that was in it. And they went through and they got beat up badly on their pass through. And they were scheduled to make one more pass through before they headed home. And they didn't have long to go to get home. I mean, it was making landfall near Panama City, and they were based at Keesler because the winds weren't that strong over at Keesler. But the aircraft commander looked at it, having experienced that last horrific pass through, getting beat up, and made the decision, no, we can't go back in. And I'll tell you, I've flown with this particular aircraft commander multiple times. He is he's not one to be afraid of anything. He's flown through tons of storms. He knows what is up against, but he just felt that it wasn't safe. And so if we don't feel that it's safe to go back in, we're not going back in. We'll say that just isn't what we're doing, and we go home.
Thanks, Warren. And something you guys do, I'm not sure about this year, but other years, the hurricane hunters do travel around the country during Hurricane Awareness Week. I assume people could find out more about that if it does happen on the Hurricane Center page. Is that correct?
It would be on the Hurricane Center page, and also keep an eye on your local weather service office page. We have tended to do that every year, but we alternate between the East Coast and the Gulf Coast. But of course, budgets being what they are, and other requirements being what they are, we're never completely sure what's going to happen with it. So if we do have it happen this year, it would be probably in the early May timeframe. So I would say, and this year would be a Gulf Coast year. So if you're interested in seeing one of these aircraft, keep an eye this year on the Gulf Coast, next year on the East Coast. Keep an eye on the local National Weather Service office pages or the Hurricane Center website, and they'll probably be, or Google is your friend in terms of searching for it, and that was where you'd be finding information on where and when those tours would occur.
Last question quickly from the teacher. Wanted to know, do you ever take science teachers on missions, and how would they apply for something like that? Is that something that happens?
That, as much as I would like to say Ms. Hastings can come along, that would be a bit of a stretch. Typically on the Air Force aircraft, we only take media. That's why, like I said, I was so surprised when I saw John Cusack on that one time. I mean, he must have gone pretty high up in Air Force public affairs to get that okay. And it was based upon the fact that he was doing research for the movie. And then the NOAA aircraft, while the strictures are not quite as strict, science teachers, that's going to be, now, if you got a job and say, second career doing, print media or something, maybe, but I wish I could be more encouraging, but that's going to be a bit of a tough one to get on board.
Hey, Warren, thank you so much. We really appreciate you taking the time, just as a friend, and just being out there and answering the questions for folks. We really appreciate all that you do. And again, thank you for being with us today.
It was my pleasure. Had a great time, and I hope everyone got something out of it.
Well, folks out there, as we close out our program today, we want to let you know about our next CoCoRaHS Weather Talk webinar. And that will be all about NOAA's Weather Prediction Center's heavy rainfall products. Meteorologist Greg Galena will talk about those. That's coming up in a few months, the end of April, actually the last day of April, April 30th. We'll have more on our website about that. And we've got a bunch of other webinars planned for the fall and winter of next year. So you won't want to miss them. And again, we record them all if you can't make it. Before we forget, before signing off today, please take the survey. It's going to pop up on your screen. So until we meet again, this is Henry Regis for the rest of the CoCoRaHS team saying goodbye for now, and have a great afternoon.